Hello and welcome back. It's puzzle time with Sudoku Sleuth, and we're back to looking after the top 20 puzzles once again and taking a look at them and seeing what we can solve. Now, today's puzzle is all about linear algebra, and you can see a thumbnail here of Sleuth basically presenting to nobody. So I hope that's not going to be the case for today's video, that it somehow is so boring that basically there are no students whatsoever in the classroom. Everybody's left. Now, I think I need to probably have a bit of a confession before we look at today's puzzle, because today's puzzle is number 9 on the list. And I imagine some of you are going to have the question of, well, Sleuth, what happened to number 12? And Sleuth, what happened to number 10? And all I'm going to say is I just restarted my machine once after I started this series, and unfortunately my previous numbering of what were the top 20 has completely changed. So I'm certainly not going to lose track of the fact that I owe you up to this point at least another 2 fantastic puzzles, and I will find them, but just forgive the fact that number 9 may not be what was number 10, may not be what was number 11. It's clearly all a little bit messed up than how it was intended at the beginning. Now, I still think this is exactly what I should have done. If there is a security hotfix out there, apply it on your machine, apply it on your devices, restart it. Don't get hacked because you just wanted to remember something. Anyway, that's a long explanation for why I'm missing a couple of puzzles. Don't worry, you don't need to bring it to my attention. Now, let's take a look at what we have in store for today, shall we? So we have Arithmetic Quiz by Nasty 2. That's how I'm going to stick with it, with exceptionally simple rule sets. So we have a normal Sudoku rule sets apply. So that means the digits 1 to 9 in every row, every column, and every box. Kind of helpfully, it's almost like here are the 9 maths questions that you need to answer and, labeled already or numbered from 1 to 9. Now, 2 cell circles enclose 2-digit numbers. So, for example, this cell here is a 2-digit number. And 3 cell circles, hopefully not too many of them, there's one there. Seems to be there's only one on the grid, enclose 3-digit numbers. Now, what it doesn't say in the rule set is kind of the obvious, that we need to actually make this linear algebra equations make sense. So we have all of the digits 1 to 9. This is a 2-cell digit, therefore it's a 2-digit number. We're going to multiply it by something and we're going to end up with another 2-digit number. And that is all the clues that we have. Just lots and lots of maths. If you don't enjoy maths, this is definitely not the puzzle for you. If you do enjoy it, or you're up for the challenge, you want to look at why this is a puzzle that's rated amongst the top 10 of all time for this difficulty rating, you can play along with the link in the description down below as per usual. And with that said, let me restart the clock and see how I get on. Now, I'm almost going to tackle them in this order. 1, 2, 3, 4, 5, 6, 7, 8, 9. Kind of a bit of a clue that I'm going to go with. And in box 1, what's fascinating about this is we've already placed 1, 2, and 3. So you can see already that the minimum digit I can have here is 4 and 5. And I can't multiply it by 1, aside from the fact that I'd repeat the digits. 1 is not available in the first row. I can multiply it by 2. And in fact, I can only multiply it by 2 because if I multiply it by 3, I'll end up with a 3-digit number, and this is not true here. I need a 2-digit number. So this is definitely a 2, this is definitely a 4, and I'm going to say this is definitely a 9, because whatever this is, it's a number that's greater than 45 multiplied by 2, it is definitely 90 something. Now, it's not 45 because 45 times 2 would be 90. I can put a 0 in the software, but it's not a allowed digit today. So we have 6 would be 92, repeating the 2. No, we don't. 47 would be 94, would be repeating the 4. We're not doing that either. 48, I think, is the only available possibility now, because we've already placed the 9. So 48, 96, and to finish the top row, we need 3, 5, and 7. Hopefully this is going to all hold up. What do we have in here next? We got 4 digits that will sum up to a 2-digit value. Now, we've already placed a 2, so this is either 1 or 3, and I don't think it can be 3. To get to 3, as in 30 or higher, in 4 digits, I think is impossible, because, 9, 8, 7, 6, all added, that's the maximum I can make this, would be 30. We've already covered the 0. So that's not a 3, that's a 1. Now, I am left with, frankly, very high digits to try and get to a number that's under 20. Now, the minimum I can make this is 5, 6, because we've already placed 1, 2, 3, and 4. I've already placed 1 and 2, mind you, in box 2. So the minimum I can make this is 3, 4. So that's 7, that's 11. Absolute minimum is 18. Now, clearly, the absolute maximum I can have is 19, given I cannot get to 20 or higher. So 3, 4, I absolutely need to place the lower digit in all of these, the 3. I need to place the 5 for sure in here. It could have been 3, 4, 5, but I've already placed the 5. So let me explain that. This could have been 3, 4, 5. Let's go with 3 and 5. That would be an 8. 5 is no longer available. I would have had to put 6 and 7 in here. 13 and 8, 21. I've broken the puzzle. So this is, in fact, definitely 3, 4. There's definitely a 5 in here, and there is 5, 6, or 7. So 7 plus either a 5, 6, which is 11, that's 18, or 5, 7, which is a 12, plus the 7, which is 19. Look at that, though. Whatever digit I don't place in here, let's say it's the 7, I'm going to have to place in there, which I can't do. The only digit I can place in here would be the 6. So this is, in fact, fixed as well. That's 19, that's 5 and 7. And these are 6 and 8 as the remaining 2 digits. We are now left with 6, 9 in the box. We are now left with 5, 7, and 8. So essentially we've got 6 times 90 something, or 9 times 60 something. So 90 times 6 is 540. So I'm fairly sure this is going to have to be a 5. Even if I make this 68 times 9, even if it's times 10, I can only get it to 680. And 6 is not available as an option. So this is definitely a 5. These are not 5. This is 7 and 8. This is 6 and 9. These are now 1, 2, and 4. I probably can, we've got an even, likely an even digit in here. I don't know if the 1 is even possible. So if this is, the only way this would be a 1 is this a 9 times 67. 9 times 67. 9 times 67. I think it's more than 500, isn't it? 9 times 67, so that's 670 minus the 67. So yeah, that's 600 and something. So not doing that. 1 is not in here. I almost feel like the only way I'm going to be able to solve this is to try the different combos. It's either 6 times 97 or 98, and does it leave a sensible digit in here? Or, did I say, yeah, 6 times 97 or 98, or 9 times 67 or 68. So let's see if we can do the 9 times. That's probably a little bit easier first. This is where you're going to see me do a lot of arithmetic, get it totally wrong, and mess up this entire puzzle. And if I feel very unconfident, if such a word exists, I am going to get a calculator out rather than break this puzzle. So I guess continue this trick where I'm multiplying by 10 and taking away the digit. So if it's 67, it's 670 minus 67. That doesn't work. If it's 68, it's 680 minus 68. Doesn't work. So this has to be the 9. This has to be the 6. Right. 97, that's 540 plus 42. It will be 582. So 782 looks pretty solid to me. If it's 98, it's 540 plus 48, which is 588. And that's clearly not going to work. I'd have repeated the 8 3 times. 8, 8, and 8. So that's 7. That's 8. I'm fairly sure I said that would be 2, yeah. 7 and 6 is 42, plus the 540, 582. Okay. Hopefully the remaining arithmetic's a little bit easier than this. Right, kind of obvious start. I'm adding 2 digits. Even if these are the maximum, which they can't be because there's a 9-8. In fact, I'll come back to the 9-8. I'm pretty sure I can place them in here. But even if these are 9-8, that's 17 is absolute maximum. So this is a 1. There's no question about it. Now, notice the 9-8 in here. I don't think I can put 9 and 8. So I have to place 9 and 8 on the left-hand column. And I can only place them in here. You see, if I put 9 and 8 on there, all I'm actually saying is 80 minus some digit, a single digit, mind you, is going to get me to another single digit. What kind of nonsense is that? So that's not 8 or 9. One is not here. I think 1 has to be here for the same reason. I've got 2 digits that add up to a 2-digit number, and it's not going to be 20. It's going to be 1 in here for sure. Leaving these to be 2, 3, and 7, I'm going to say. So 8 and 2, 9 and 2 will not work because it gets us to 10, which is not allowed. 11, which repeats the 1, it's not possible. 8 and 3 would be 11, doesn't work. 8 and 7 would be 15, which also doesn't work. It repeats the 5. This is not an 8. That's a 9. That's an 8. Now, 9 and 3 gets us to 12. 9 and 7 gets us to 16. Both options are available for the moment. I need to make that a multiple, though. If it's 12, I have 2 and 6, but I don't because I've already placed the 2. 3 and 4, I also don't because I've already placed the 4. And I don't think there are any other factors that I can use that I haven't placed. So I don't think this can be 12. This has to be 16. This has to be a 7. And this has to be 2 and 8, presumably. It's not 1 times 16, and it's not 4 times 4. So that's 2 and 8, and this is 5, 3 and 5. Right, 12. Let's see if I can do this first. 8 minus 2 would be 6. That doesn't work. That's 3. That's 5. That's 2. Right. We need 2 digits that add up to 12. 3, 9 is actually available. I can put a 9 in here and a 3 in there. 4, 8, both are available, as in kind of either way. This could be the 4, this could be the 4, this could be the 8, this could be the 8. 5 and 7 is not available. I've already used it in the box. Well, we don't know what these are, and I'm not about to pencil mark a whole bunch of options. Actually, what I can do, though, is say, where does this 8 go in this box? It's not in here. It's not in this row. It's not in this cell. It's definitely in these 2 cells. Just, you know, Sudoku. And this 8, eliminating it from here. So that is a 4-8 pair. That's not 3, 9. I'm still not pencil marking all these options. 3, 5, I need to place a 3 on this row. It can only be in here. Right, now I'm comfortable doing this. 1, 2, 3, 4, 5, 6, 7, 9? Not 9. And presumably this is 7 and 9. I know where the 9 goes this time. 7 and 9. I need to place 1, 2, 4 again. Interesting. This time this is not the 2. I'm going to keep assuming I've done this correctly and just see what else comes. How am I interpreting this equation? So some digit, I'm going to interpret is equal to this digit divided by this digit. And whatever this digit is equal to this digit divided by kind of, because it's in brackets, subtraction of this digit from this one. I don't actually have to suffer this much though. If I do a bit of Sudoku, I can actually guess what these numbers are, can't I? So this is 2, 3, and 5. This is 1, 4, and 6. Now, I'm not getting 5 as a division of anything from a single digit. 25 divided by 5, maybe. But, I'm already repeating the 5 multiple times. That's not a 5. I'm clearly not dividing 1 by anything. 4 would have to be 4 divided by 2 to equal 2. I've repeated the 2's and everything. I'm pretty sure that's a 6. I'm pretty sure that's 2 or 3. In fact, I actually know this is a 3. Therefore, that's a 2. And what we have in here is something that is divided by something else to equal 2. That's not 2, that's not 6. What do we have in here? So the way I'm going to interpret these again is some 2 digits is equal to sum of these 2 digits, which is equal to a digit, which is equal to the sum of 2 digits. Now the way I'm going to look at this is actually, what we're saying is we have a number in here that, mind you, is not 9 nor 8, that has 3 different and unique ways of getting to it. Now, I think the only number that's possible in here is a 7. I know I'm cheating a bit. I'm actually solving equation 9 before 8, but I think it will help us. Now, the reason I say it's 7, well, aside from the fact that 6 is taken, is, any digit under 6, under 7, even the 6 is either a 1-5 pair or a 2-4 pair. I can't get to it in a third way. I can't repeat the 3 twice. But with 7, what I can do is a 3 and 4, not 5, 1, 5 in here. And then I have 2, 5, and then I have 1, 6. I don't have 2, 5 though in this one. You can see 2, 5 tells us this is the 1, 6 pair. This is the 2, 6 pair. I have an 8 in here. This is the 1 or 6. And this is, no, that's the 2 or 5. And I actually know the order of that. That's 2, that's 5. And then I have the 1 and 6. And I know the order of these because of these earlier placed digits. Now I have 5 plus some digit, well, some 2 cell digit is equal to 2 clearly. Otherwise we'd repeat the 1. So this has to be higher than 15. It's not 16, not 17, not 18. It can only be 19. With a 4 in here to get to 24. I'm sure I can probably tidy this up a bit. That's 4, that's 3, that's 8, that's 4. I can do... Let's do the algebra. It's a little bit harder. What these could be. I mean, clearly I can just place them. So, trying to get to 2. What are the remaining allowed digits in this row? We've got 1, 4, 5, 8, and 9. Now, this is not 1. This is not 9. It's not going to be an odd digit divided by something to get to 2. It's 4 or 8. Now, if it's 4, these 2 digits would have to be subtracted to get to 2. And none of them are 2 apart. They're either 1 apart, 3 apart, or more, 4 apart, like 9 minus 5, 9 minus 4. So I'm pretty sure this is the 8. None of these are 8. We need to get to 4 apart in here, which could be 5, 1 or 9, 5. None of these are 4. Clearly the higher digit is on this end. No, sorry. So it's either 9, 5 or 5, 1. Fortunately, only Sudoku, I think, will actually solve this for us. It's 1 and 5. These are not 1 or 5. We're left with 4 and 9. We have now 24 is equal to some digit plus the multiplication of these 3. We need 3, 6, and 7. That looks a bit uncomfortable if I'm honest. That's not 7. It's not a factor of 24, so that's not the 7. I think the only way this works is 6, 7, 3. That's 4 times the 6 to get to 24. Right, the rest of it is fairly straightforward from here. 3, 5, that's 3. These are not 3. These are not 7. These are not 4. You can do better. That's 1, that's 2, that's 4, that's 1, that's 9. 9, not 8. 4, 6, and 9, and got 6 and 8, and 5 and 7, and 3. And if I've not made any mistakes, that's the solution to today's puzzle. It's phenomenal. Definitely deserves to be amongst the top 10. Highly approachable, I would say, if you're just good with numbers, which I imagine most Sudoku players are, just with all of the arithmetic it takes with killer cages and whatnot. But I absolutely loved it. Thank you very much, and I'm sorry if I'm getting your handle incorrect, mnasty2. But thank you so much for creating it and sharing it with all of us. It was, a pleasure to play. And I hope you've enjoyed today's video, and see you back for the next one. Bye for now.